Hello and welcome to the next lecture of the object-oriented programming. So, firstly, I want to uh, talk a little bit about an extra task. Unfortunately, I still haven't received the correct answer, so I still have received the answers without letters. That's true, and most things have been done, but still the address of some functions like printf or write file are not working. So they are just hard coded as numbers. It's not correct because they will be different from run to run. They may be different from run to run. They may be different from different execution environment. For example, I have taken the sources that you have sent me as a solutions, put it in my Visual Studio, and it doesn't work. And it crashes with the access to the address that you expect to be a write file function, which is not correct in my system. So the goal is to find this function on your own. So I want to show you a little bit how it works because I really think that it's definitely one of the uh, basic concepts that malware may use. So you have to be aware of how to do that and how to reduce that. So let's start from just a simple application. So I'm not discussing the stuff that how to remove if constructions, for constructions, functions, and all this stuff. So I'm now will write a regular C code because the rest stuff you know how to do. But right now I want to show you how to find the address of write file. Okay. Uh, this will be the last hint, and I'll give you last one more week, and I hope that you will send me the correct answer. I really think that's pretty important how to do that. You will not get a lot of pluses this time, simply because I give you some hints about that. But anyway, you will get some of them, which is also good. So let's work in. So let's start from the basic stuff. And this is the main and org C org V, sorry, char star org V, yes, return 0. And let's try to do some special function like int test return 0. So now I want int int tr equals test. And starting from that, I want to find the address of REST function that I'm interested in. So let's start to, oh, sorry, I'm starting Arkanoid. I'm working on the same solution that we are working on today. Yeah, it's not working because it's Arkanoid. Stop this. So you see, this is a bold type, so this will be default by pressing F5. And if I want to start another one, I just can do debug, start new instance, step into new instance, and it will work, I hope. Yeah. So now I want to go through debugger and memory to watch on how it works. And right now I'm getting address. So let's copy that. Let's just do stuff like int ptr2 equals write file, int ptr3 equals printf. So to do a write file, I need to include windows.h. Of course, in final Windows h, yeah. So in the final solution, you don't need those includes at all. You just may not use them. It's okay. You really need a string description of this. So something like this is enough. Sorry, is enough. So let's go ahead and try to look at the addresses. Oh, I have forgot. So let's change this because I fail every time and don't want to. So yeah, this is our three variables. So this is PTR, it's a hex. So this is copy. So this is test. What's that? Why is that? So why is differ? Copy. Let's look at. No, copy. Yes. Anyway, this you see it's pretty different addresses. Oh, I just don't understand why it's differ. Oh, maybe we'll look at it later. Ah, yeah, I see. We can remove those. I think that this is a cause. Yeah, let's look, and this is 730, still differ, and this will be the okay 20 and 2b. So let's record them. I know because it's due to the jump table. I think the code that it generates is a little bit different. I just want to mention the different addresses. So test write file printf. Let's run again. Just okay, okay. Build. Didn't complete successfully. Why that? Okay, let's rebuild. Succeeded. Okay, for some reason was the printer because the virus or potential unwanted software. You see, wow, it is it looks like a virus. It doesn't allow me to run a virus. Huh. I can't develop a virus in Visual Studio. That's funny. Let's rebuild this. Why it allows me to do that the previous time, but not right now? Due to our internet connection, maybe? Yeah. Okay, let's remove. Let's disconnect. Try. Okay. Let's rebuild. Rebuild. Visual Studio doesn't. Oh, you see, it's an internet connection, so it sends all my binaries to Microsoft for some reason. It's my copyright for some reason why it doesn't allow me to write a virus, so I have to be online offline. That's funny. It's the latest Visual Studio, I believe, and now they know that I'm trying to do some viruses. It's not good. Okay, copy. Now it's like this. Now it's like this. 771b is the same, and oh, and it is different. So you see, those are different. The write file is looks the same from run to run, and that's why you decided that it will be the constant. But unfortunately, it's not, because this is because I'm running Visual Studio. So if I reboot, let me reboot, maybe it will help. Where my notepad? So this is write file, write file. Due to the fact, so I'm now will reboot and explain you why these addresses may be different from system to system. I think that after rebooting, this address will be changed. So why is that? Because it depends on how does in what order DLLs are loaded. So the idea is that, for example, kernel32.dll, this is the file, the load library, the dynamic library that works on uh, on whole over system. So it's basically included in all uh, binaries in all processes, and that's why it is loaded to the same address. So because of we have a lot of processes right now working. We can press and look and like, okay, we, we see that we have a lot of processes. All of them has a kernel 32 loaded, and that's why this address, let's try, this address will be the same because every time it will be loaded to the same address. So test and printf may be loaded on different addresses, as we have noticed. Let's look, copy, and check it with our old address. So this is the old address. You see it's different. It's the same, and now it's different. 4020 is the same, but here is CE. You see it's different because from at the moment that the window starts, it knows that kernel 32 will be at the same addresses on all processes, but this address will be different from run to run of Windows exactly. So if you reboot your PC and will try to reboot everything, you will get the same problem that I have. So anyway, you have to get this name dynamically. And now I'll show you how to do that in regular C. So this is how this address we want to uh, find, this one, and will start to search this address starting from our own address like this. So let's look and try to PTR. Let's cast it. Something like this. Let's try to call test. Why does this stuff has 730 and this stuff has A in the beginning? Because of the jump table. So let's go to disassembly and look at this. So it's called by PTR. This is A F11, and you see it's a jump table. So in the beginning of our binary, you have a lot of stuff like E9, which is jump, to some relative address. It's easy to replace addresses, and this is how compiler generate the code. So generate this table instead of going to the exact code of test, which is 730. That's why our uh, debugger showed us that test itself is one address, but pointer to it is another address. You see, this one is 00A and this one is 730, which is different. But we don't care actually. The goal is to find the beginning of our portable executable header. So, of course, I don't remember the exact stuff, so I will have to uh, enable networking. I know that it will not allow me to. Let me enable this build. Maybe it will allow me to run. I hope it will not be. Oh no, it looks like a virus again. Why that? I can't take a pointer to my own function. Oh. Okay, let's download PE format. Uh, so let's look at this. Maybe it will help. So yeah. Portable executable, where it is. So let's look at this. Oh, why? Oh yeah, here we are. So yeah, date stamp. So in the beginning it will be 5A4D, which is MZ. It will be a start of header. So we have to find our start of program, which will be, we know, at least aligned by page. So it will be an address. So PE, let's try to start a function like int detect PE, and it will be an address int order, and if, or like order equals order and 0x 1 2 3 4 1 2 3 4 1 2 3 1 2 3. Yeah, this is how we align address to page. Now while and unsigned short this and this not equal to 5a for d, 0x 5a for d, not equal while this, oh, one bracket, yeah, order minus equal 0x 1000 and return order. So this is a simple code that searches for portable executable header. Now we don't need to call it. This will be our portable executable. So int pe base equals to ptr. Now what I need is find the export. Oh, sorry, import table. Let's look at import table. So this is import table. So this is 70. This will be a 70. So 8 bytes. So it will be 78. 78, and one more. So it will be int export table base equal to PE base plus 0x78 plus 0x8. It's a second record, and it will be a 4-byte for input table, and RVE, it's a relative address which will have to be added to the base. So, oh no, not to the base, I need code base RVE, so it will be related from this one, base of code 28. So let's int base code base RVA equals to 7 plus image base base of code image base. I think it's 38 34 0x 34, and I hope I'm not mistaken. So int star. Now how I can read this. So of course it's better to create some structures, but right now it's very draft code just to show you how it's possible to do. And export table base will be this one, star in star, yes. Now, so you can use without this, you can use this operator without letters, so it's still possible. Now let's continue. We need maybe to do some addition or something. We will check it. So export table, export table, export table, export table. Okay. Of course, I don't remember export table format. So let's look at this huge diagram. There it is. Export, export. Sorry, I don't need export. I need import, because yes, import. Not export, but import. Import, here we are, import table. This is structures of import. It's descriptors and how it works. RE 420 import. Kernel will be the first record. after it will be loaded. Like this. Uh, uh, Maybe this. I just don't really remember. PE header, optional. I don't need this. Loading section import. Where is import? It's that. So, okay, PE format import table. Import. Let's look at this. Side import table. Let's anti headers, optional header, that directories import table. Okay. So image, it's optional. Data directories import. Uh, import. Its original first. It will be the first. It points to the first func, which is for kernel 32, I believe. Calls the address of hint and the function name. It's a descriptor, so it's a table of descriptors like this with a name. So name, here we are, this is the name, and this name will be choose the relative address of DLL name. So we will check it. Okay, I think that so far it's enough. Let's try. Oh, yeah, I know that I have to remove this. No, let's disconnect. Solution. I don't need this. I then just rebuild. Let's go ahead. Okay, test the base, which will be this. Okay, copy right here. This is our, oh, sorry. This is our portable executable. Yeah, PE, it's MZ. Awesome. Now I need RV base. RV base is 0. It's not correct. 32. Mm-hmm. Mm-hmm. Oh, maybe. Okay, let's look at export table. Here we are. Copy. Plus 78. So 70. It looks not good. Let's go ahead and check again. So it's anti-headers, which is header. Yeah, I need anti-header in the beginning and pass from DOS header. Why this format doesn't help me? DOS stub, yes, and what it's a DOS stub, yes. This is relative to 5045. Okay. It's some extra offset. I forgot. 5045, 5045. Here we are. 005045. Yes, is it true? 1, 2, 3, 4, 5, 6, 7, 8. It's an 8, and this is a beginning. So 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So it looks like the C, D, E, F. So the C plus. So I need to calculate. Yes. Okay. Let it be this. Then let it be address short int. Let's update it. I just really, this is a fixed size, so it's better to uh, uh, just write the correct structures, but plus 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 plus, yeah, 10, 20, Yeah, copy. Now let's check 3. Oh, it's not working. It's kind of strange. Okay. Mm-hmm. You see, the real application development is something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now it's this and this, and let's calculate it hard coded in Z, blah blah. Right, it's 4, 5, 5, 0. Ah, uh, 5, 0, 4, 5. PE. Looks like it's a bubble here. 5, 0. It's 4, 5, 5, 0. 4, 5, 5, 0. 5, 0. 10. Copy. Yeah. And now I hope it will work. Now RVR base still 0. Why that? For machine, number of sections. Okay. Signature, file header, empty headers. It's empty headers in MS-DOS. MS-DOS header. No offset over here. Why that? Okay. 0, and this will be this, yeah. 34. Okay, let's check. It's a base. I think that I have missed like not some special case. We need to after no, I need 4 bytes, and I need some address 00. So this is a machine. Machine number of sections, which is oh, actually yes. For C, number of sections. Let's check whether it is EF0, EF0. Yeah, it's much better. So looks like we need short and 4550, 50. Let's try. Actually, this is a buggy machine. RVR base F0 copy. Yes. RVR base. Yeah, now we have something. Yes, it's RVR base. And now table base is this 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Yeah, looks like it's an offset. Okay, fine. Export table base. It should be so int export table base. This is RVA relative virtual address equals plus PE base. Looks like this. Now detect PE, detect NT. Let's split this. Detect NT, NT, int NT base equals PE base. Now this will be NT base, this will be EE base. Now it should be an export table base. Sorry, export, it should be import, import, import. Okay, okay, let's copy, paste this. Okay, and let's look at the import table base original timestamp for chain 1 2 3 4th 1 2 3 4th. This one will be the name. Let's check that this is the name of DLL. Int DLL name equals to EE base plus this stuff star int star plus 0x 0 4 8 12. It's C. Let's check. It's a DLL copy, copy, copy. What that? Oh yeah, I have copied that one name. Okay, let it be after, and this is VC runtime 140D DLL. Oh, that's nice. Now we can look at import of this guy. So let's copy. Let's see, system 32. Maybe it will find it for me. Windows system 32. Okay, I really don't remember where it's placed. I think it's in path somewhere. I don't remember. So I just want to check import export. Yeah, here we are. So we can move it here. No. Yeah, this guy. This is image import export. Export has, here we are, all functions. Let's try to find the printf. So actually this guy show me the full structure. Does it has a printf? No, it doesn't. Kernel 32, then copy the CRT. Nice. Where is printf? A very weak export. Okay. So you see how we can find the DLL name. Next record after that, so we can do a plus 0x the size of the record, which is 1, 2, 3, 4, 5, 20. So it's 20 bytes. And let's check the second DLL name. Second DLL UCRT based. Let's look. Maybe this guy has a printf. Import descriptor. No, I need an export. Blah 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 blah. CRT. It looks better. 20. Okay. Also the same. It's has a RVA, so it has a records, and this will be the first record, and then the number of record. So sorry. ordinal first chunk, or this will be the first record, depending on whether it is 0 or not. So you can go through and find export. So you can find these. If this name is correct, you can just need this will be a pointer to the next record. So this will be a pointer to the first chunk. Over here, it's import name. It's an import function, or whether you can find the any function, then find the p header of this base library again, and find export table, and then you will find the address of printf abc. Oh, yeah, looks like this is our client f p putchar. Here we are. We have a putchar which we can find. Not only write file, we can just find a putchar. So it's even not bad to do the code like this. Find the import. So find the second, which is usrt, vcusrt dll. Then you can look at any record, find again the PE of it, find the export table, find the record of printf or putchar, and this is how you'll find your putchar, and then do the rest with it, or even fprintf. So I hope you have now all requirements of how to do that. Hope you will do that. Go ahead, and still I'm waiting for one more week, and I hope I will receive the correct solution. So the best way is to go and use a write file. So I have checked the first and second record. Some third or fourth record will be kernel 32, so it definitely will be in the import section. So you can find the write file the same way. Just check the DLL name as a kernel 32 DLL and go to the export section of it. So not that hard. So now let's go back to our Arkanoid, and today I want to do more syntax stuff for C++ wrapping. So we have done, let's build it, let's run it. We have an Arkanoid, a very simple stuff. And what we have an Arkanoid game, we have canvas, which is not that good naming. So we have drawing, which is refactored. So everything looks fine here. And drawing H, which is also looks not bad. So now I want to say that drawing itself is a set of functions that helps us to do some stuff for Bresenham, Murphy algorithms. So we'll keep it as a procedural, simply because those algorithms are described in any articles as a procedural approach. But rest stuff will be definitely in C++. So let's look at what we have in Canvas. Canvas, we have stuff called, we have a set pixel with a handle, which is a fixed image. And all stuff is working with a fixed image. A fixed image create, destroy, set pixel like this, like that, blending, alpha, and all these things. So let's refactor that. But before we start, I want you to, firstly, we don't need this. We can close this. And close this, and I want to commit our changes that we have stored from previous time. Let's commit them. Commit. Why it is so slow? So yeah, we haven't committed. Refactoring of drawing. Commit. it also have changed. We have also changed the canvas.cpp simply because canvas is depending on drawing. So that's why we have changed the drawing, and canvas also have changed. So let's start from doing our library with canvas in fully object-oriented way. So what we see here, we see a set of functions which all depend on a fixed image. So it will be replaced on the canvas. We have a font which is not working so far. Green line means that we don't have those functions implemented. Fine, we'll implement them if we wish. So we have a fixed color as a type. It's a union, just to better access to the bit fields, RGB. RGB alpha channel. Alpha channel is a alpha blending, and we have even functions for blending, alpha blending. And what we have a fixed image with a width, height, data size, and bitmap. We have a image draw type. It's simply enumeration where it's used. Let's look. It's used in draw bar and set pixel and in draw image, I think. Yes. FX font no use so far, where it's used in this green function, which is not used so far. So let's remove this. We are not using fonts. Okay. Text draw type. We don't need this. We'll maybe add it later. Not right now. Now let's start from. So right now, FX color is a simply union with the ulong and just helper function, which is static. So this again is good enough. So ulong is unsigned long, which is depend on architecture. So it's not good. I want to change it to something that, so pixel sizes will also always be 4 bytes, but if we will change our architecture to 64, it will not work. So let's look at our Arkanoid game, and we have a bar color, fixed color, basics. We have a color, and this have to be a color. We don't need a ulong here at all. A color, a color, a color, a color, a color, a color, a color. RGB. Actually, it may be just unsigned char. Let's also add a new type def as a color component, which is char. Color component. This, this, this. Components here is just a struct, and we force 8 bits, so it's okay. It's correct. No, it's correct. Yeah. So I think this is all requirements, so we don't need this. I have errors over here. Let's keep them so far. The fixed result we have to rename, so it will be a canvas. Let's rename it here without replacement because we will check them while we will do refactoring. So it's a canvas awk, canvas general, wrong arguments. So maybe we'll check it, change it. It's a canvas result. Actually, this is a C style. For C++, it have to be enumeration. Let's do enumeration. It's much better. It will be more typing because this is just text replacement, but enumeration and C++ compiler will check and change, will check the types for us. That will not assign something not in enumeration. It will give us some new constraint. It's much better. So let's do this. Enum canvas error, canvas draw result. Let's check it, name it like this, and we name it success. General failure, general failure, wrong argument, wrong, wrong arg, no object, no object, wrong state, wrong state, wrong. Actually, some of you may say that, come on, object-oriented style of handling errors is exceptions. Correct, but I want to do step by step, so to show you how it works uh, uh, in C style and in object-oriented way. So we will replace some of them on exceptions for sure, and true. So, and true false also not nice because it have to be something like boolean. So actually this type may be changed simply because sometimes result of drawing may be not exception, because sometimes we just need to know that we have put the um, area while drawing, but we have drawn it anyway. So let's keep it for now. We don't need this type defs, not need, because it's not a type def, it's just a union. Now let's create a struct but class canvas. Canvas will have, we need a metric. So unsigned int, let it be unsigned long, which will be a metric. To define, no, not unsigned, but long, a metric will be a coordinate. So it will be a width, height, it will be size t. It's basic type for sizes. It will be a fixed color, and we need to change a fixed color on color, or like canvas pixel. Let's rename it like this. It will be a pixel. So not a color, it's pixel. No, pixel has a position. Let it be pixel color, canvas color. Yeah, it's more advanced than just a color, which is just unsigned int, which is used for outside world, but so far it's a canvas color. Okay. It's a canvas and a canvas color bitmap, or it's a color, or like data. It's data and data size. Okay. Everything will be private. We don't need to show everything, which will be to outside world. We have already p prefix. We can add an extra m underscore, which is mean that it's a member of a class. So it's a field with m underscore. It's a typical for members. Sometimes also used like this. M actually from method. Method is a part of class that it's about behavior. So we'll have some public methods and private methods. So let's look at draw type, copy blending. Okay, let's rename it and move it upper, because we will have all declarations next inside this class. So it will be a canvas draw type. Canvas draw type, and we will replace it. This is a good example of enumeration, simply because this is not an error or something like this. It's just really different ways to draw. Okay, let's now create, destroy, basic stuff. Create, destroy. So the good thing is that in object-oriented way, we have defaults of this is default stuff for creation and destruction. So this is a class which is will be a description to all objects. So looks like a pattern for objects. It's not an object, it's a type of those objects who will be canvases. It's in defining the structure and behavior. This is structure, this will be our behavior, not because of public, just because of our methods over here. Those functions are methods. And the thing is that any object has a life cycle. So let's get back to 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 I want just to draw some schemas. So any object has a life cycle. It starts from creation. Oh, sorry, creation. And after creation, which is done by constructor, so from nothing, uh, start point. Okay, too lazy. Okay, which is object. It is a constructor. Constructor. It's a method, special method that creates an object. It's called before object created. So the typical algorithm will be its memory allocation, because our object will be in memory and its structure will be kept in memory. And as you remember, the ID of the object, identification, will be an address of this memory. So secondly, constructor call, or maybe really a set of constructors, maybe not only one, we'll talk about later. Three is life of object, so it's methods call maybe. So object do something, we call some methods for this, and then it is destroyed. So it's a destructor call, and fifth is memory free, because we allocated and free. This is how this is a lifetime of an object. So constructor is a special method, destructor is a special method. The thing is that C++ always thinks that each object has a constructor, at least one, actually at least two, and a destructor. So you can not define them, and C++ will do it for you. And there is two ways how we can do allocation and destruction. Actually, three ways. First, we can allocate an object in the stack. So we can do, let's say, canvas. So it's at some point of function canvas C, and it will be canvas object in stack. So this stuff will be allocated in stack, or we can canvas allocate it in heap. It will be a pointer, so it will be a canvas object in heap, and we will call operator new canvas. This is arguments for constructors. So any object may have one, two, or more constructors, and only one destructor because it doesn't have arguments. So the thing is that, so blah blah blah, some lifetime, canvas lifetime, and some end of this scope. This is a scope. It may be a function, a method, just a scope inside a function, anything. It's a for loop or whatever. So this stuff for two scenarios actually, it can be allocated from stack. It will be allocated in stack and call the default constructor. The constructor here will be called. We'll check it in runtime for sure. And here is just a pointer to the heap. So calling operator new, and this stuff will be allocated in heap. So memory allocation here happens in stack, just as regular int variable or whatever, just in stack. And new will call memory allocation here in heap. In a heap, like you call malloc or heap allocate or whatever, because any operating system may have its own heaps, and it may have different of them. So actually, the truth is that by default, you may say by default, application thinks that you have to treat heaps differently. Heaps for C++ objects, calling new, and also you may have code like this to actually malloc canvas star malloc size of canvas. We'll definitely check this code. I just want to add some theory about it. We can do a 3 and heap alloc get process heap, something like this. It's a heap alloc. So what is the differences between all of them? So this object will be allocated in stack, and the good thing is that at the end of the scope, at this particular line, compiler will generate automatically the code that frees this object. So it will generate a code that will call destructor and call a memory free. Just basically remove or move a stack pointer up to remove to deallocate it from the stack. But for those three guys, this code will not generate destruction and free, simply because it was located in a heap, and compiler have no idea how this object will be used. It may be this pointer may be passed somewhere, executed or call it or duplicate or whatever. So that's why it doesn't generate the code for free and destruction. So if you allocate something on you, it's your own ability, it's your own responsibility to free it. To free it, you have to use a particular operator. Uh, delete. Delete. Oh, sorry. So, what is the difference between this line and these two lines? The difference is that this guy will not only allocate memory, but in it also call a constructor function. Each object thinks that at the beginning of the life, after memory was allocated, it may do some specific stuff for setup. So just allocate the particular amount of memory, set up handles for some files, maybe take some locks, create or set up some basic on default values of its fields or whatever. So any object may have a constructor. Uh, and this guy, new operator, it's an operator, it's a keyword, will not only allocate memory, but it also call a constructor. If you use just malloc and heap alloc, it will not do call a constructor. The memory will be allocated, and you may treat this, but the state of this object, it will not be basic setup state as the object thinks. It will be some garbage over there. So you may call some methods from here, but uh, in most cases, it will not be correct and you will get some bugs because the state of this heap is not, it will be undeclared, unknown, and in most cases, not most cases, but always, it's better to say always, objects treat that their state are the same as they expected after some constructor calls. So they expect each object, if you define some class or struct with a constructor, REST behavior, REST methods expect that constructor was called. So some initiation of this object state was created. And this looks very understandable because object is something, it's an abstraction that not always has, not only has an identity and behavior, it also has some initiation function and destruction function. because because object itself may have to allocate some buffers. For example, our canvas will have to allocate memory for um, data for image, and so we need to do that. Differences between malloc and hyperloc is that hyperloc is Windows way of allocation memory. Malloc is a wrapper under this, and actually it's all about like how standard library is implemented, how operating system gives you ability to for application to create heaps. So basically this is Windows way, this is standard way, and both of them will work in Windows. I'm not sure, but I think that malloc will call hyperloc somewhere inside, or maybe it use another option. So heaps are really depend on how operating system and standard library implements. So this is still possible. You may say that you can do and call constructor after that. It's a method. So you can do that actually. Uh, I will show you how to do that. And you can do it manually. But firstly, if you have an operator which do all for you. Secondly, you need only one line without instead of two. But secondly, the good thing is that new operator may be overloaded. So some system specific stuff, some libraries, sometimes real tries implements their own new operator to track on missing or leaked objects, to track where object was allocated, and when the application completes, it checks the rest object that wasn't allocated that it track on, and give you ability like, oh, we have some object leaked, so this object was allocated there, and so on. So you can um, overload this operator. If you allocate object like this, it's not good in always. Um, you have to do two lines to call a constructor. You may forgot to call a constructor. You may and then you will never forget it. And secondly, it uses a better heap for which is optimized for C++ object, not for malloc heap. So or heap alloc, it may be some different alignment stuff, some security stuff, because object may be shuffled within the heap better way than it does in malloc or heap alloc, and more and more and more. So never use stuff like this. Use new operator to allocate. So you have so far only two ways to allocate your object, to create your object, to allocate it on stack, allocate it on heap. But I said that you have three ways. What is the third one? The third one is actually to allocate an array. Canvas uh, 5, something like this. You may allocate them as an array of objects. And this one, you have to allocate like deallocate it like this. So the idea is that these two operators, new with the square brackets and new without square brackets, are different. So we'll do it in real world and check how it works, all of them. Just this is just a draft. The difference is, so never mix those operators, which means that you have to, or you may sort of do like this. It will be an array. So the idea is that array itself may have a special structure that delete square brackets knows. And that's why if you just use delete for heap, let's say array, I think that this stuff will fail and give you some in a good some error in runtime. So you have to use the same operator if you allocate it with the square brackets, you have to delete it with square brackets. If you allocate it without square brackets, you have to delete it without square brackets. Again, it all because of structure of heap. This is looks like this. Okay, let's return back and create and replace those stuff on constructors. So constructors is a special methods. Again, it might have 1, 0, 1, 2, 3, or more constructors. All of them have to be in different uh, header, so they have to differ in arguments. So by default, C++ thinks that it has two default constructors. It's a default constructor without arguments. You have a copy constructor, which will be a copy constructor will call automatically when you copy from one object to another. I will show you an example. So if you do something like it's a copy constructor call, which means that you are creating a new canvas AAA object. AAA is an object, this is a type. So a object you are creating from this copy, and this line will call for copy constructor. So this one is default, and it will so these two constructors are default ones, and they will be generated by C++ compiler automatically if you are not create them, but it will set all stuff by default in 0, and copy will just copy all fields and nothing more. So in most cases, it's better to implement them yourself. So these two constructors are default ones. Now let's implement the constructor that we have here. It's a canvas that has it's an output, so it's a metric width, a metric height. Okay, and this is a destructor. Destructor looks like this, special symbol, and it has no arguments. It's a destructor. So you have constructors, destructor. This is default stuff. So this is how you can create a canvas and destroy it. So let's complete our factoring, and next time we'll look at all examples in runtime. So I'll now just copy all these uh, methods here. So let's look at it. It's a set pixel with some result. Hmm. Uh, so now you see it's a fixed image set pixels, a fixed image set pixel. So this is the name of object. This was the old name of the object as a fixed image. Now we are canvas. Because everything, all of these methods now it's a part of canvas, there are no need to add a canvas name. So we just can remove this. It's a set pixel. Also, first argument always a name of in all these functions, a name of an object. It will be a this pointer as a keyword, so we don't need this. It will be a special calling convention for call methods, which is called this call, when the pointer to an object or pass to a method through the register, through the specific register, EBX or RBX, depending on architecture and calling convention. So we can remove this. It's a destination, draw image with transformation, and yes, it's a line, pick. The same is here. So this one is global, so keep it clean. Image draw image. I don't need this. It was green. So now let's rename int on metric. It will be coordinate, 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 int on this place. Now fx color selection a, not a, but canvas color. It was a canvas color, canvas color, canvas color. Yeah, correct. Now u long with the metric. A metric. Okay. Fx image, fx image as a canvas. And let's replace fx result as void so far. It's a canvas draw type, canvas draw type, and replace bool as boolean. Awesome. This is how we add our methods that we have previously defined. Now we can remove this and go ahead and do some canvas replacements here. So first, what I need to do, I need to do some replacements, like int now have to be replaced on a metric, current document. Okay, now u long replaced on a metric also. Now fx result replace on void. Fx image replace on canvas. Fx color replace on canvas color. Let's keep it now. Yeah, boolean. Bool place. Yes. Now let's start to do some specific fx set pixel handle. Yeah, we are doing this. Actually, we have. This stuff have to be replaced back. Canvas set pixel function. Canvas set function. Sorry, canvas set pixel function. It will be a p handle set pixel like this. This will be like this. Keep it like this. Canvas init library. Current document, no. Current project, yes. Okay. Now fix color, which is 0. No more image. This now how names are created. So this is constructors, and I actually need two more constructors. Let's create them. Canvas. It's a constructor default one. It's a default constructor. This is a copy constructor. And this is our custom constructor. This just do some default initialization. This will copy them, and this one will do like this. So canvas. Okay, what fields we have? We will have to initiate init them. So the default way, sorry, the default is like this: width, height, data size equals 0, equals 0, 0, no. So to do some economy, we have a special syntax which is initialization list, which can do like this: 0, 0, and null. Because some fields may be not as simple types or int or something like this, it's better to keep initialization list in the same order as it's declared. Got to do like this. And then we don't need this. Okay, this is our default constructor. Now copy. Copy constructor looks like this. Width will be other.width. Height will be height. Data size will be data size, and this will be null because we need to allocate it. Okay, if this not null, we don't need, it's our destination is we can do this, or we can not to, you see, we can write every time like this, but we can do it without it. It will be the same syntax. Okay, it's a copy. Now creation with a width and height. So again, we can define like this. It will be a width, it will be a height, and it will be a data size, which will be width multiply height. Oh, let it be 0 so far. It will be calculated. Here are the check for arguments. This is not actual. We'll never call a constructor if we have not allocate memory for image. And this is constructor, so it's a start. So bitmap will always be not null. always be null. Sorry, no need to check this. Let's replace it on size of a color, or it's better to say canvas color data. P data. It's error handling so far. We can't handle it like this. Error handling. Next time we'll do it. Let's add a to do. Now, with no, this, no, this, data size, data, canvas color, and no return. Fine. Destroy, it's a destructor. To call destructor, we can do this, 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 it's never null, and if empty data not null, oh, free assign m no, like this. And now let's complete this stuff. I think we'll complete it next time, and we'll show you how it works after our replacements. So now today we have discussed constructors and destructors. It's a huge theme, so we'll talk about it next time in more details. I think it's more on time, but I insist that next week is better for you to take this example, or maybe write your own, not a canvas, but create a copy constructor, default constructor, some custom ones, and play with a different code like this, and look in debugger how it is allocated, where are those addresses, what are the contents of those addresses. Look at disassembler, look at the way in the order of constructors are called, and so on. So just play with it. We'll talk all these examples next time after we complete this part of refactoring. For today, it's all. Thank you.